I spent 2 years on a boat factory production line in the southeast. I laid fiberglass, poured foam, mounted hardware, and wired consoles on boats that retailed for $40,000 to $70,000. And I will never buy one. Not because boats are bad, I love boats, but because I watched what went into them every single day and I watched what got skipped when we were behind on quota. The guy signing the check at the dealership has no idea what's hiding under that shiny gel coat, and the dealership isn't going to tell him. So I will. Let's start with the one that costs people the most money, the transom. That vertical wall at the back of your boat holding your outboard engines. On a center console running twin 150 horsepower engines, that transom is absorbing thousands of pounds of thrust and vibration every time you're on plane. It is the single most critical structural component on a fishing boat, and the majority of boats in the $20,000 to $80,000 range still use plywood inside that transom. Plywood, wrapped in fiberglass, exposed to a saltwater environment. A marine surveyor named David Pascoe, the most respected voice in boat construction for over 40 years, documented a Sea Ray 390 Express with completely wasted hull stringers after only 11 years. He found the fiberglass covering was porous as a sea strainer. On the bayliner side, an owner of a $126,000 3388 found totally rotten stringers at 5 years old. When he contacted Bayliner, the service representative admitted they use Alaskan cedar laminated and stapled together. The fiberglass encapsulation was full of pinholes. Meanwhile, composite transom material like Coosa board has been available for decades. It absorbs only 1% water and has a 50-year warranty. And it costs about 2.5 times more per sheet than marine plywood. On a $60,000 boat, we're talking maybe an extra $800 in material. Scout Boats has been 100% composite since 1989. Everglades, Contender, Ranger eliminated wood transoms back in the late 80s. The technology is not new. The decision to skip it is about margin, not engineering. But the transom is only part of the problem. Let's talk about what the hull itself is made of. Proper gel coat thickness is 15 to 20 mils. That's 15 to 20 thousandths of an inch. Gelcoat is brittle by nature. It shrinks 4 to 7% during cure and has less than 1% elongation. If the thickness varies, and on budget boats it always does, you get spider cracks. A Nautic Star 231 Coastal developed spider cracks at 44 engine hours, not 44,000 miles, 44 hours. Brand new seaborne boats showed spider cracks sitting on the dealer lot. Underneath the gel coat is where the real cost cutting happens. There are 4 tiers of fiberglass layup. At the top is vacuum resin infusion, where dry fabric gets pulled tight under vacuum and resin flows through with 0 air voids. Builders like Intrepid, CV, and Everglades use this process. Next is 100% hand-laid cloth, where workers place pre-cut biaxial and triaxial fabric by hand according to a laminate schedule. Scout does this on every boat they build. Third is the combination method, a chopper gun skin coat topped with 1 or 2 hand-laid layers. This is the most common approach in this price range, and it's where the marketing gets deceptive. A builder can call a boat hand-laid if just 1 structural layer is placed by hand over a chopper gun base, and at the bottom, full chopper gun. A worker sprays randomly chopped 1 to 2 inch glass strands mixed with resin into the mold. The result depends almost entirely on operator skill. Thickness varies, strength varies, air pockets form, and the finished laminate carries excess resin that adds weight without adding strength. On the factory floor, the difference between hand-laid and chopper gun is hours of labor. Scout's own sales team has said their hand-laid process costs 7 to 8 times more in labor than chopper gun production. That cost has to go somewhere, and on a $40,000 bay boat, it usually gets cut. Now here's the one that made me lose sleep. Pour-in foam. Most builders fill hull cavities with 2 pound per cubic foot polyurethane foam. It's the cheapest option that meets Coast Guard flotation requirements. But here's what the brochure won't mention. Those flotation requirements only apply to boats under 20 feet. Your 22-foot center console, your 24-foot bay boat, that 26-foot fishing machine you just financed, zero federal flotation requirement. If it swamps, it sinks. Period. Even on boats that do have foam, the stuff absorbs water over time. 5 to 6% of the cells are open, creating pathways for moisture. A tracker. 16-footer that was torn apart yielded over 300 pounds of water trapped in its foam. That's 300 pounds of dead weight the owner had been hauling around for years without knowing it, burning extra fuel and stressing the hull. The worst design in the entire industry is foaming aluminum fuel tanks into place under the deck. When that tank fails in 15 to 20 years, and it will fail, you have to destroy the entire foam structure to get to it. Replacement runs $8,000 to $15,000 on a center console. I've seen it quoted at $30,000 on larger boats. If you're finding this useful, hit subscribe. I break down what's really inside these boats every week. Now let's talk about the hardware bolted onto your hull. The difference between 304 stainless steel and 316 stainless steel is 2 to 3% molybdenum. You cannot see the difference. They look identical. But 304 develops rust pitting within 36 months of saltwater exposure. The British Stainless Steel Association says flatly that 304 should not be considered suitable for seawater. Guess which grade is cheaper and shows up on budget boats. Same story with wiring. Marine standards require tinned stranded copper with adhesive-lined heat shrink on every connection. Budget boats use automotive-grade wire with strands up to 12% smaller than proper marine cable, routed through the bilge instead of up high where it belongs. I've seen wire nuts on brand new boats. Wire nuts are specifically prohibited by ABYC marine wiring standards. So what does your $60,000 boat actually cost to build? The raw hull materials, your fiberglass, resin, Gelcoat, foam, and hardware run about $5,000 to $8,000. That's 8 to 13% of what you paid. Factory labor adds another $5,000 to $10,000, and the fiberglass laminators doing the actual structural work earn a median of about $16 an hour. The twin Yamaha F150 engines bolted to the back? Those alone represent 46 to 53% of the total retail price. The dealer adds 15 to 25% on top. The fiberglass hull you think you're paying for is actually the cheapest part of the whole package. So how do you protect yourself? 4 things. First, the tap test. Buy a $10 plastic hammer and tap every inch of the transom, hull sides, and deck. Solid laminate gives you a sharp, crisp wrap with the hammer bouncing back. Delamination or wet core gives you a dull thud where the hammer feels absorbed. Compare port side to starboard. Any difference is a red flag. Second, get a moisture meter. An Electrophysics CT33. Costs about $160. On its scale, 0 to 15% reads dry. 20% and above means walk away. The hull needs to be out of the water at least 24 hours before testing. Third, the Transom flex test. Trim the motor all the way up, grab the lower unit, and push and pull hard while someone watches the transom from the dock. A good transom shows 0 movement. If you see flex, that plywood inside is compromised. And fourth, always hire a NAMS or SAMS certified marine surveyor. $20 to $25 per foot. On a 24-foot boat, that's about $500. It's the cheapest insurance you'll ever buy. Never trust the seller's word. Never trust the dealer's inspection. Get your own set of eyes on it. I'm not here to tell you not to buy a boat. I'm here to tell you what I saw so you can buy a smarter one. If you want to know which specific brands I'd actually trust with my own money, that video is on screen right now.